Electrical power systems are the most important invention of the 20th century, more important than transistors, the internet, or even the computer. You may ask me why, and it's also the first time I've ever heard of it. The answer is simple. All these inventions need electricity to exist in the first place. I know. Electrical power systems are like that child forgotten by history. It's the reason all these inventions exist. Electrical power systems has three parts: generation, transmission, and distribution. Only a turbine and a generator are needed to generate electricity. The turbine's movement interacts with the generator. A generator consists of a rotor, two magnets, and a stator. The movement generated by the turbine causes the rotor to generate cycles. The rotor generates a magnetic field, which induces the formation of an electric current in the stator, which allows the formation of electricity. To create the movement, there are different ways, such as hydraulic, thermal, solar, and nuclear. These generators operate under the principles of alternating current. Which means that their cycles operate in a sinusoidal manner. And you were saying that you were never going to use trigonometry never again in your life. Bro, math is everywhere. You can't escape from it! The cycle of a generator works in this way. In the first quarter of a turn, the magnetic current is converted into electrical energy up to a maximum point, which is pi over 2. From this point, the electrical energy decreases to 0 in pi. Up to this point, the rotor is halfway through. When 3/4 of a turn is made, the opposite process occurs, which reaches an electric current at a maximum negative point in 3 pi over 2. When a quarter of a turn is missing, the electrical energy rises to 0 in 2 pi, which completes the cycle of an AC generator. This explains how a generator generates a positive current in the middle cycle and a negative current in the second half. This process is performed at a speed of 60 cycles per second. In other words, at 60 Hz. This electricity then goes to a transformer, which converts these 12 kilovolts generated to 220 kilovolts, which are transported in a high voltage line until they then reach a substation, which decreases this voltage to 13 kilovolts and is transported in primary lines to have a final process in a transformer, which decreases its voltage according to Colombian regulations to 127 volts with a range of plus minus 10%, which ends up being a range of 139 to 114 volts in secondary lines, and this is the voltage, ladies and gentlemen, that reaches our homes, and it's what we consume daily.